is I've shown you both ends of that beam. So on the previous assignment, we were just focused in on one end. That's all we could see and was worried about was that one beam and that one column right there. Now I'm showing you both ends. So this is what would be handed out as a drafter. This is what we would receive. It's already gone from the design stage where the fabrication, or the facility says this is what we want this kind of a unit. So different companies came in, they started engineering all the piping, all the other vessels and everything that needed to be out there and on there. And they said, all right, civil structural people, we want all this off the ground. How can we make that work? So then the civil structural designers went through and they said, well, we've got this span right here. We need to support this. We'll put a column there. We'll put a pipe rack. We've got all this pipe that's coming from this location all the way over to here. We need to run all that pipe over there. Let's do a pipe rack because it's not just right there. Sometimes it's let's do a T-support, kind of like what we see outside these doors. Does anybody take Highway 69 like to Nederland, like by the airport and stuff? That facility that's going up in between Twin City Highway and 69, they're still in the civil structural phase of that. Most of the areas are. When you ride by there and you see all those square pillars, those aren't 4x4s. A lot of those, at a minimum, I'd say they're probably 16, 18-inch squares at a minimum, all of those. But those are the pallets they're pushing down into there to get that compression, get that strength up under whatever's gonna be out there. Sometimes it's vessels, but it's the civil structural that does that. So right now, they're mainly focusing on the below ground stuff. I don't go by there that much. Every few weeks or so, I'll ride by there and I'll notice a few changes and stuff. But I was going by there fairly frequently back during the semester, during the long semester, for whatever reason. But I was noticing pretty regular. They were out there pushing those pilings down and stuff. I've seen them do stuff like that out there at DD6. But that's all still civil structural. Remember, civil structural starts at the top of the concrete and goes down. Anything steel above that concrete is still civil structural. All the rebar, all the footings underneath, that's all civil structural. All the beams, columns that you're gonna see start going up pretty soon. Once they start getting all those things built, whatever's gonna be sitting on those areas with all those little squares, it'll look like somebody took a handful of square toothpicks and just threw them in the ground or something. Those are gonna have something up there. They're supporting something. At some point or another, they're gonna start pouring slabs out there. As they pour slabs, then you're gonna start seeing something similar to those footings that you see, something similar to what you see out in parking lots and stuff with light poles, those concrete piers that stick up. If you're riding by and you see some of those sticking up, maybe they're close enough to the highway, don't get in a wreck. Go take the feeder and stop over there or something. Don't pick up any hitchhikers in that area, remember? But you'll see that you're gonna see anchor bolts sticking up out of a bunch of those. And in the future, you might see like a bunch of those little piers sticking up out of the ground with the anchor bolts sticking up, usually 4. And then the next thing you're gonna see is all these columns set on there. And then you see the beams starting to hang between them, the bracing starting to go between them. That's all the structural part once it gets up into that. So that's what it is. Remember, this has to be 100% accurate before it gets out there. Not that place over there. They can actually drop it down on the ground probably and make changes because there's nothing going on out there yet. There's no actual facility, no unit, no processing being done out there. So there's no flammable gases. I imagine they have the freedom of doing stuff like that out there. But on your normal basis as a structural drafter, you're working off this erection drawing saying that we're gonna build this. I need to tell them what they need to do to build that. We need a column this size, this tall, with holes at this location. An anchor bolt on the bottom with these holes, anchor plate at the bottom, base plate at the bottom, with holes in this pattern to match what's gonna be out there when we pour the concrete. And then we're gonna have this beam up here that needs to be this long with angles on each end, held back 1/4 of an inch, and it's gonna drop down in there, and those holes are gonna match. And they're gonna move on to the next one, into the next one, into the next one. So we as a drafter look at it and say, well, what's happening? On this one right here, as we talked about before, we've got a center of column to center of column dimension, 20' 0. We say, well, let's focus on this end, just like we did on that last assignment. We say on this end, we've got a beam that's attaching to the column flange. Our beam is a W12 by 26. Our column is a W14 by 48. But what else can we pull from that picture? Well, we know that this end is going to have about -7 inches. We know that our angle gauges in here, our center to center is going to be either 3.5 or 5.5. We know that possibly by now, after doing that first assignment, you've seen that the W12s are on the 3 rows. So you're going to start to learn stuff like that. I can tell you how to judge it, but right now, look it up on the chart. On this other end over here, we're attaching to a flange over here. So our minus dimension on this end, our column is a W12, is going to be about -6 inches. So this as a drafter would be what we would be working off of to detail that member right there. To take that piece right there and say, here's how long it needs to be. Put the angles on this end. Here's how many rows. So that is what you're going to be doing on this one, is filling in that last sheet. I need to go get some copies of that too. So on your first sheet, on the left-hand side, you've got 3 beams attaching the column flanges on each end. On the right-hand side, numbers 4 through 6, you've got 3 beam details that you're doing. Those are attaching to column webs on each end. So on these first 3, about -7 for this one, -6 for this one, -4 over here, -7 over there, -7, -8. We can guesstimate on that. And right now, like I said, it's a matter of just you looking at it saying, before I even let somebody else check it, I want to make sure that I'm at least kind of going, or maybe you're just jetting out of here and not even thinking about it till, Saturday. All right, here's a quick check for it. If I look back at this piece right here, number 3, and on this end over here, I see -1/4 inch, 1/8 of an inch, 3/16 of an inch. I know something's wrong because that was attaching to the flange. It's going to be about -7, or about -7. About -8 on that right end. Over here on these, we know that our minus dimension for all of these is going to be in the 1/8 to 3/16, 5/16 possible. I don't think we'll get that heavy though. But it's going to be right around 1/8 to 3/16 as a norm. The second page that I gave you, beam detail 1B. On this one, end to end, you've got a column flange on one end, a column web on the other end. Once again, when we're calculating those ends though, we're calculating just based on that end. Then we will look at the other one. What happens on that left end over there has nothing to do with what happens on this right hand end. We're going to calculate those 5 items just like we did on that first assignment for one end, and we're going to push that out of our head. You'll learn to carry some stuff forward. But for right now, you calculate one end, you push it out. Then you look at the other end and say, okay, I've got a beam that is this size attaching to a column blank of this size. A column web or a column flange. You've only got 2 choices there. So on this one, it's opposite on each end. So on one end, it's going to be minus about half of what that size is. This one's going to be about -9 because we're attaching to the flange of a W18. This one's going to be about -5 because we're attaching to the flange of a W10. This end over here, all we know is it's going to be about the 1/8 to whatever range. Over here, 1/8 to whatever range. Over here, 1/8 to whatever, 1/8 to whatever. Over here, about -5, about -4. So what you're doing is, and like I said, I'm gonna go get some more copies of that third sheet here in a minute. I forgot I need to print some more of those out. So what you've got here is a total of 12 pictures between those first 2 handout pages. you're gonna need 6 of these sheets as a minimum. So all I have in your packet right there is gonna be the one. So I will go get some more of these in a minute. But once again, you're gonna be filling out each end, just like you did before. The number of rows. The only thing that you don't have is a measurement on this one. I just wanted to make sure y'all remember where that came from. So you've got your distance between rows. So if your beam has 2 rows, you're just gonna write 3 inches right there. If your beam has 3 rows, you're gonna say, well, there's 1, there's 2, let me draw a line, 3 inches right here for that measurement, 3 inches for that measurement. If yours has 5 rows, there's 1, there's 2, so you're gonna draw a line for number 3, line for number 4, line for number 5, you're gonna draw those lines out and get 3 inches between each one. Mr. P, this one's a W6 and it's 6 1/8 deep, and this one's a W18 by 145, and it's really 18.5 inches deep, but the pictures are the same. It's a sketch. This is something that if you got a structural job, you could actually make you something like this or a picture like this that you could print out and just write your stuff on just to get you started on what you're doing. It doesn't matter how tall that piece is and how many rows you could physically put in between those 2 little lines that I drew. That number is coming off that chart. So here's what's new. The new part, now that you're looking at it on its own page, its own detail. Right over here, don't worry about that 2-AA. We'll get to that later on. We're not adding that much new today. Just ignore that where it says that. Here's your center to center. Here's your gauge. You're gonna be filling those out. Your number of rows and your minus dimension, just like before. You're gonna be doing it on each end. The only difference on each end is that measurement right there. Then, this measurement right here. This parentheses on the bottom. If you look back at your sheet, the first sheet of this packet, like I said, I'm gonna print quite a few of those, so if y'all need extras, if you wanna use the one I gave you to make up some, use it as a note sheet, you're more than welcome to. I'll print more if I need to. So on number 1 right here, you've got a W12 by 26 beam attaching to a column flange on the left end of W14 by 48, a column flange on the right hand end of a W12 by 35, and you've got a distance of 20 foot 0 center to center on the column. That is called your overall dimension. That's just what it's referred to. The measurement center to center of the column. It doesn't matter if your column is turned in that direction or if your column is turned in this direction, attaching to the web. It doesn't matter. Like I said, we always dimension to the centers of the columns. So that 20-foot measurement right here on number 1. Here's your number for it right here. That 20-foot dimension is going to go in that area right there. That is your overall dimension. If the parentheses are too small, that's okay. Just write it underneath it or something. Don't stress over something like that. That is where your overall measurement goes. Your overall measurement being the center to center on your columns. Everybody got that? On this dimension right here, you will see that that measurement from end to end represents that finished product when it leaves the fabrication shop, gets loaded onto a truck, driven out to some facility, some refinery, and brought in there, hooked onto with the crane and lifted up into position. So whether it's attaching to the flange or the web of that column, it doesn't matter. As long as we minus the right numbers, that thing should slide right down in between there. So what we're gonna do is we're gonna take this measurement right here, our overall dimension. We're gonna subtract that number, and we're gonna subtract that number. Coincidence that that number has a minus in it? Subtraction in it, in the parentheses, called a minus dimension. So that's what we do. We take that overall, and we say this finished product that is gonna leave and just go perfectly into place. We subtracted on each end. There's how much we subtracted. Could that number be a 0? Yes. Could that number be a plus? Yes, but we're not ready for that. We're tip of the iceberg. There's so many different variations in structural steel because we have to meet the needs of what's going up. There is no standard in the pipe department that says this is what we're gonna do. Just about every pipe spool that goes through those pipe departments is different. They say, well, we're ExxonMobil, why don't you build this facility for us? Sure, we'll build it for you. Another company says, hey, they got that nice new facility y'all built for them. Why don't you build it for us over here? Sure. Where you got room? What size area do you have for us? That's what's gonna dictate how everything is set up. So even though those two are built right across the road from each other doing the exact same product, literally trucks pulling up and saying, which one of y'all needs a truck to? You know, who needs a truck? I'll turn left or right, it doesn't matter. Doing the exact same product is gonna be a whole different layout because it's all based on where's the tank gonna be for this project, where's this vessel, this piece of equipment. Now we got a pipe between them. Now the structural people have to come back and say, okay, well, this is what you're doing on this project. We need to support this run because it's 20 feet. Over on that last project, it went 6 feet this way and it turned 90 because it had to go this direction, not that way. So as a structural drafter, we have to look at each individual one. And then we have to look at each end of that one and say, what do I do here? What do I do here? And we're gonna write those minus dimensions down. Then we're gonna do the math equation. We're gonna say overall center dimension minus this equals, and we're gonna put that number right there where my cursor is, in front of those parentheses. That's referred to as a shipping length. So when we're putting all this stuff on a truck, we need to know how long of a trailer do we need. That's why it's kind of referred to as, I think, as a shipping length. That's how big that unit is gonna be when it leaves to go to the next step. When it is fully fabricated. Inside the parentheses right here, W something. Remember, we're talking about the beam. So if I go back to that sheet, first sheet, our beam is a W12 by 26. So after we tell them the shipping length, the cut length, the end-to-end measurement for that piece once it leaves the fabrication shop, once we tell them this number right here, we're gonna tell them this piece is a W12 by 26 by, and we have to tell them how long to cut that off. Because some point or another, that beam is probably gonna be made in normally just a whole different shop and warehouse type thing than what that W shape would be made in. Those angles are gonna be made over here in your regular, pretty much standard around here fabrication shops. Most of them have one big area where they do nothing but those W shapes. The beams, the channels, stuff like that. They do the big heavy members. And then lots of times you have another facility, another shop over there that does nothing but plates. Maybe half of it does plates. Another half of it does angles. So whenever that person goes to make this beam, he's gonna pull up this drawing that we as drafters, we as detailers create. And they're gonna say, all right, I'm making this one right here. Go get me a W12 by 26 and cut it this long. And then bring it down here. And if we had other things attaching to it, just like we saw out there, that handrail and stuff, maybe we've got plates on our beam. We're gonna detail this piece out. Right now, we're just talking about the ends of it.
So what dimension goes at the end? The shipping length or the actual?
No, I'm gonna tell you,
Okay.
I'm gonna tell you in just a second how we find that. So we're gonna tell them, for the person over in this facility that is working on the W shapes, go get this size member and cut it this length. That length we know is gonna be held back 1/4 of an inch right here. So W12 by, so we started out, I'm gonna run through the formulas again. We had our overall minus our minus dimension, minus our minus dimension, gave us our shipping length right here, and then we're gonna tell them information about that W shape, W12 by 26 by. We've gotta tell them a length on that. So once I do this number right here, minus this, and I get this number right here, my shipping length, I can say, well, minus 1/4 on this end, minus 1/4 on this end, that's my length. So it's all formulas when you look at it. You don't have to be a math person, you don't have to like to do algebra or anything like that. But if you just write it down and say, oh, there's not a lot of A's and B's and X's and stuff like that, but that's a formula. Web thickness divided by 2, that's a formula. So don't be scared of the math. Don't be worried about the math in structural steel. It is what it is. As drafters, at some point or another in all industries, it comes down to a measurement. Just because we do schematics in E&I, we say, here's a nice picture, at some point or another, somebody's gonna have to calculate that conduit, all that wire that's going through there, all the little fittings for that instrumentation stuff. So at some point, measurements are involved in all forms of drafting. So we've got to tell that person how long to cut that member. And then once again, this is going to be done in one shop, those are probably going to be done in another shop. They're going to say, all right, on this end, we need 2 angles with this gauge, this center to center. On this end, we need 2 angles with this gauge, this center to center. And we need 1 beam this long. Here's the twist. So this number minus our minus dimensions gave us our shipping length. That's the end to end of the angles and everything. And we said that to make this, we already told them some info about the angles. For this, we need a W12 by 26 by our length. We don't show 1/16 of an inch measurements in this box right here. Everybody see that? That value right there, we do not show in 1/16 of an inch increments. How do we eliminate that? We don't show that dimension. That dimension could be 1/4 of an inch, it could be 5/16. It doesn't matter. When we go to write this length down here, we say that number minus those 2 numbers equals this, minus 1/4, minus 1/4. If it gives us an answer that's in 1/16 of an inch, we're just gonna drop a 1/16 off of it, because we're not gonna show that 5/16 anyway. It's just another rule. Lots of rules in drafting. A lot of them can be answered just by looking at this stuff that I had up on the desk the other day. Well, Mr. P, why didn't you put it up on the desk? Well, I want y'all to understand that it's over there. If y'all want it, if y'all need it, go grab it. Bring it to your desk if you need to.
So that one in the parentheses, you're subtracting a 1/4 inch from it?
Which one? This one right here in the parentheses?
Yes.
We're subtracting really 1/2 inch.
Well.
A 1/4 here and a 1/4 here, yes.
Every time?
Yep. That's that extra cost of having to pay to have those 100% square cut. We're not gonna pay that. We're gonna do 10 beams for the cost of one, and we're gonna do it quicker than that machine's gonna square cut that one. Probably not quicker, but we're not spending the money on the machine.
So the shipping length minus 1/2 inch.
Yep. And then if it's in 16ths, knock another one off. Why? Not sure, just a rule. I don't know why.
Knock the 16th off.
If it's in 16ths. So if when I do the math, this one's okay being in 16ths, but when I subtract a 1/2 inch, so if I get a number right here, 10 foot 11 and 9/16, I'm not gonna tell them to cut that member minus 1/4, 10 foot 11 and 1/16. I'm gonna tell them 10 foot 11. I'm gonna knock a 16th off. It's just a rule. So that's the only step that you're doing differently. You're carrying that value from that other sheet over to here, your overall dimension from end to end. And then you're doing the math, you're saying this minus those, and you're writing that value right here. And then you're looking at that other sheet saying what size is it? You're writing that right there.
So, I got a question, you kinda confused me there. So say it was 11, or whatever you said, and 9/16. So you're knocking it back down to,
I took the
8.
half off for the quarters. I took the half off because of the quarter and quarter on each end.
okay,
Which left me 11 foot something and 1/16.
oh, okay. I was thinking the other way around, you
Now,
ended
from
up.
here to here, we're taking this number minus a quarter to get this value. And that is the only rule really for that is if it's in a 16th, knock another one off. If your answer right there is something in 13/16, you're gonna put something in 3/4. You'll knock
Okay,
16th
yeah,
off.
that's what I was getting at.
Mhm.
Cause I thought you went from 9/16 all the way down.
Because of that rule, no. No, I went because of the minus quarter.
Okay.
Yeah, no, it wasn't just automatically down to knocking it off to an even inch.
Okay.
Yeah. So remember that, y'all catch that, you're knocking a 16th off. So if it's 1/16, 3/16, 13/16, 9/16, just knock 1/16 off. If you get an answer of something in 7/16 right here, excuse me, an answer of something in 7/16 right here, you're gonna write 3/8. You're gonna knock 1/16 off of this answer.
Good question about that one. So for all of those dimensions, we're just going off of number 1?
For this detail right here.
Okay.
So what I want y'all to do to tell me which one it is right here after the B. That's where you're gonna put what number it is, number 1, number 2, number 3, 4, 5, all the way up to number 12.
And we do that for both of those?
That'll be like number 1, that will be number 2 on the bottom, then you have another sheet, number 3, number 4. Don't forget to put your names on your sheets, I'm gonna print some more. So those of you that were taking notes and writing that down, that's what it takes, trust me. In my eyes, unless you have a photographic memory to learn everything for structural steel, because there are so many, you hit this thing where you say, okay, that's a standard, yes. And then right after, it's like, nope. That's a standard, except. That's what I'm watching. Now we can see what's going on. So a lot of these, it's this every time, have a unless or except after it. So just when you think that, all right, this is a rut, it's good, I'm doing this, I'm chugging along, bam, there's another train track that cuts off. Which way's the switch go?
So we aren't writing anything on the first 2 sheets?
Correct. I don't need the first 2 sheets back. That's just where you pull your info from. So you're gonna write each one of those numbers. The numbers are 1 through 12 on those problems. That's where you'll write that at right here. So the only new difference is you're gonna pull that overall from that sheet and write it here from those first 2 sheets. It goes there. So remember, that's, like I said, that if you just think of it as formulas, it's just like when you drive here, I go to this point, then I go here, then I go here, then I go here. Same thing with this. You pull this number over, then you go here, minus this, and you put it there. Then you go minus this, and put it there. Except if it's a 16th, knock one. In a 16th of an inch increment, knock one off. All right, I'm gonna go get some more copies of that second page. Like I said, because and see on the 4th page that I gave you, I forgot about this one. This one right here shows you exactly where you will be filling information in. Each one of those asterisks represents something that you will fill in. Each one of those asterisks, you should have somewhere either in your brain or in your notes saying what goes there.
Do you have any copies of the past homework assignment?
Yes.
Can I have one of those books?
Yes, yeah, I've got some up there. When I get back over there, let's go grab those for copies. So head on up there. So any questions before I go get copies? Go ahead, Madam Rep.